let G be infinite cyclic. Then for each n and n, there is a unique subgroup of G of index n and G. Since G is infinite cyclic, G is isomorphic to Z. For each n and n, nz is a subgroup of Z with index n. Since this index is precisely the size of Z mod nz. But that is the size of the set of cosets nz 1 plus nz n minus 1 plus nz, which is equal to n. By proposition, each subgroup of Z has form nz. Thus, nz is the unique subgroup of Z. With index n in Z. Now, let phi from G to Z be an isomorphism. Such an isomorphism exists because G is infinite cyclic and therefore isomorphic to Z. Let G be in G such that little g generates big G. Then phi of G must be equal to 1. So phi of G to the n is equal to n. And for any k in the integers, without loss of generality, we can assume k is positive. We have that phi of G to the n to the k is equal to phi of G to the n applied k times, which is just n applied k times, which is and k. But here this should be plus. Because phi is going to the additive group. So it's then clear that phi of the group generated by g to the n is nz. So the group generated by Gn is the unique subgroup of G of index n in G as desired.